function, and we're integrating using integration by parts method. Okay, so how do we go about this? Solution. So from here, let's say using integration by parts method, the formula is the integral of u dv equals uv minus the integral of v du. Okay, this is the formula for integration by parts method. And what this implies is we need to determine the value of u. We need to determine 4 values. U, we need to determine your dv, we need to look for v, and we need to know our du. So once we have determined these 4 values, we can easily integrate this. We can easily carry out our integration using integration by parts method. So how do we go about this? So let us start with u. So for u equals s squared, okay? And let me assume this is du, this is dv. So for du, I have, it's just for you to differentiate this with respect to x. So here you have dv, du to be 2x. How do you do that? You multiply 2 with x, you subtract 1 from the power, and it gives you this. Now the next one is to determine dv. So for dv now is exponential 2x, okay? So to determine the value of v, we need to integrate this to determine v. So for v now is the integral of exponential 2x with respect to x, okay? So to integrate this now, the short way of working with exponential function, you repeat this as a numerator, okay, and divide it by dividing it by the power. But before you do that, you differentiate the power first. So when you differentiate 2x with respect to x, you have 2, okay, plus the constant of integration. So when you integrate exponential function, you have this as well. So back to my formula, which says the integral of u dv equals u times v minus the integral of v du. So I can now apply this now that I determined the 4 values of u, v, dv, and v. Okay, so for u now I have s squared times, okay, for my v, which is now exponential 2x over 2, okay, which is this, minus the integral, my v, which is still exponential 2x over 2, okay? So my du now is 2x in this case, times 2x. Now when we expand this, we have s squared, okay, s squared times this, which is exponential 2x, okay, over 2. So here minus, so we factor out what is common here. The constants, we have 2, the denominator here we have 2, exponential, we have here x, okay, exponential 2x over 2, okay. So from here now, I have s squared exponential 2x over 2. So this is 1, okay. So now I have the integral of x exponential 2x, okay. So this 2 is no more there because it's already out, and I've divided it, I have 1. So here I have x in the integral of x exponential 2x, okay. So I can now resolve this using integral by part method, integration by part methods to resolve this as well. So from here I have the integral, let us focus on this part alone, which is x exponential 2x, okay. So let's assume this is our value, which is x. My dv is exponential 2x, okay. If I differentiate this with respect to x, I have my du, that is 1. If I integrate this with respect to x, okay, I have my v. So when you integrate an exponential function, okay, so what do? Repeat what you have, okay, and divide everything with 2, which is you differentiate the power, okay, and you divide it with 2 with the power after you have differentiated it, okay. So from here now, since I've determined my u, my du, my dv, and my v to be exponential 2x over 2, I can now apply my formula all over again, which is the integral of u dv, which equals u times v minus the integral of v du. So from here, my u in this case is x, okay, times my v in this case is exponential 2x over 2 minus the integral, my v in this case is exponential 2x over 2, okay, that is my v, and my du in this case is 1. Okay, so when I move on, I have it as x exponential 2x over 2 minus, when I factor out the constants, I have 1 over 2, okay, exponential 2x. Okay, so for exponential 2x, it's same as this. When I integrate exponential 2x, I have this, so I can bring it back. So here I have x, okay, exponential 2x over 2 minus 1 over 2 times, so when you integrate this, you have this exponential 2x over 2. So from here now, so I have x exponential 2x over 2, okay, so minus, so here you have, when you multiply this, you have exponential 2x over 2 times 2, that is 4. Okay, so the result of this is this. So what we now do is to substitute this back in here. Okay, so from here now that we have s squared times exponential 2x, okay, which is this, over 2 minus 1, so the integral, okay, so the integral of this now, this is the result. So we multiply this with this, so we have here minus 1 times, so here you have x, okay, bracket exponential 2x over 2 minus exponential 2x over 4. So when you open up, you have here s squared exponential 2x over 2, okay, so when you multiply everything here, you multiply this with this, you have minus x exponential 2x, okay, when you multiply this with this, you have plus exponential 2x, okay, this one is over 2, don't forget, this one is over 4 plus c, okay. So you can have your answer in this way, or you can write it in this way, looking for the LCM, which is 4, okay, 2 in 4 is 2, 2 times this is 2x squared exponential 2x minus, when you divide this with this, you have to multiply with this, you have 2x exponential 2x, okay, plus when you divide this with, you have 1, you have exponential 2x plus c. So here we have exponential 2x to be common, so we can use that to factor it out. So exponential 2x into 2x squared, okay, minus 2x, okay, plus 1 over 4 plus c. Thank you very much.